Okay, so today we will be solving binary search problem or binary implementation, iterative implementation. So like in a Java. So basically, what is a binary search? So as you know, binary search is an efficient algorithm for finding an element for from a sorted list of items, right? It works by repeatedly dividing in half, divide and we divide basically the sorted array. So it is basically used to like reduce the time complexity. If we are like going to like use a linear approach to search any element, so what will happen? Basically, what will happen? It will take more time than what. So we can do it in a better way by using binary search. So now we will see the iterative implementation for a binary search. Okay, so yeah, in a Java. So basically we will like create one sorted array. So you can say like 2 comma 3 comma 4 comma 1 comma 9 comma 10 comma 20 okay 15 comma and like 19 and suppose 22. All right. So suppose we have to like find and element in this some element in a sorted array. So suppose we have to find some x element. Okay. So it could be anything, right? So suppose I have to find a 22. Right. So in a linear way, or we can say naive or brute force approach, brute force will be what will be we will do one we will start a for loop from zero, right? We will go until the last, right? uh, place of the array, and we will check whether it is there or not. So we'll be like if x equals to uh, array of I, so just print what we have to print I, the index of a. So if we are going to execute this program, okay, so what will be the time complexity for this program? It's loading. Execute. Okay. So what will be the time complexity of this program? It will be n, right? And there is 9 elements, and we have returned 8. So at the current index 8, the element is sitting on 8th position. So what will the type complexity for this is O of log n, right? Because we are iterating to a whole array. So basically, if you are in any interview, so interviewer will ask you to like optimize this solution. So how can you optimize this? So basically, since we have given a property that array sorted, so we are going to use a binary search. Okay. So let me just comment down this. We will going to use binary search. Okay. So what is basically binary search? It has two requirements. It has one very common requirement, that is array should be like sorted. So we have our given array is already sorted, right? So and what is the approach of binary? It's divide array into half on each iteration. Okay. So so let's see the implementation. How is the like basic implementation of a binary search? So we will like create some variables. It is first we can call it uh, start, which will have the first index of an array, and second will be end. So end will be array dot length minus 1. Okay, so we have to like run the loop. Okay, so for this we will learn, we have like loop because we have to iterate, right? So how can we iterate? We will iterate from start until start is like less than equal to the end. So basically what we do in a binary search, we will take the mid element and we will check if the given x is on the right half of the so array or a left of that middle element. Okay, so to do that we have to like we have to check middle element every time, and we will change that middle element, and at the end we will find our remaining element. So we need to uh, do we have to create one middle element. Okay, so how can so we will initialize our middle element. So how can you find going to find your middle element? So basically what we can do, we'll do start plus end. Okay, and if I do divide by 2, so it because precedence of a divisor is greater than the plus, so first it will get divided, so it will be a wrong approach. So what we have to do, we will always use bracket. We will do start plus and divided by 2, so it will ensure that uh, first uh, first key every first start and end will be like addition will happen. Okay, so it is also not a very optimized way. So more optimized way will be, we will do start plus end minus start. So now you will be thinking why we have to do this. We are doing this because uh, because uh, to if suppose maybe start and end will be in a range of integer value or whatever the our data type. Okay, but when they both are combined, there are slight chance that they will like go out of the range of that particular data type. So to overcome that, to control the overflow, we will use this method. It is like better. Okay, so now we have our middle index. Okay, so if now we will check if given x equals to array of mid. If suppose our mid is found. Okay, if middle element is our what, x is at mid position, so we don't have to need to check further. We will just break our loop here, right? uh, if suppose our x is less than array of mid, right? So basically the given x is like less than, so suppose 10, it is suppose it is less than 10 and 10 is our middle. So what will happen, we have to do what, high equals to mid minus 1. We will shift our whole, sorry, not high, we have end equals to mid minus 1, so the mid will change. Okay, so end will become mid minus 1, or else we, if this condition is not true, so basically what will happen, vice versa. So it will be low equals to mid plus 1 if the given thing is on the right side. So it is not low, it is like start. Okay, start mid plus 1. Okay, so this will this is called a binary search. Basically it will take how many iterations to it will like take a log n time. What will be time complexity for this? Of sorry, log in. So let's run this program. So it is a much better approach. Okay. So see you in the next one.